Hello, good afternoon to everyone from the editorial board of the BuildUp portal. For those attending a BuildUp webinar for the first time, we are very glad to welcome you. For our returning audience, thank you for renovating your interest. This slide to recall briefly what the BuildUp portal is. BuildUp is a collaborative platform in the field of energy efficiency in buildings. It is continuously updated and it represents a key source of information on the topic of energy efficiency. You can register and become a member of the community, which allows you to upload news, events, present case studies, results from a project, and so on. We also invite you to simply navigate the portal. In the Learn section there, you will find all the podcasts of past webinars, so it is possible to listen and see previous presentations. At the end of this webinar, the link to the full presentation and the PDF deck of slides will be made available in the section Learn, in this section of the portal. You can also find upcoming webinars in the calendar section, in the events. It is a pleasure to host today's webinar entitled Designing, Constructing, and Monitoring Net Zero Energy Settlements. The purpose of this webinar is to open up to the novel Zeroplus approach for the design, construction, and monitoring of net zero energy settlements to stakeholders of energy efficiency from different fields of practice, such as architects, engineers, industry professionals, utilities, large vendors, and other building energy-related companies and project owners, and demonstrate the benefits from its implementation. The panelists are academic and industrial partners of the Zeroplus project that was launched in October 2015 and will be completed in December 2020, after successfully constructing and monitoring 4 net zero energy settlements. I would like to invite you all to contribute and participate in this webinar. You can type and send your questions in the dedicated box at the right-hand side of the screen. We'll bring these questions up at the end of the presentations and get the answers from our panelists. For the agenda of today, we'll start with a presentation on the benefits and barriers for the practical implementation of the project, then discussing the Zeroplus approach for design, construction, and monitoring, then discussing the digital monitoring and evaluation platform of the Zeroplus project, discussing also about the energy communities and how regulations and markets have changed, how this is taken into account in the project, with the case of the Italian Zeroplus settlement. Also, we will discuss the case of the Cypriot Zeroplus case study, and also discussing the benefits of for the technology provider. So without further ado, I will give the floor to Dr. Chaptai Isaac for the first presentation on the benefits and barriers for the implementation of the project. Dr. Chaptai, the floor is yours.
Thank you. So, hello and good afternoon. My name is Chaptai. I'm professor at the Department of Structural Engineering at Ben Gurion University of the Negev in Israel, and I'll be the first of a series of speakers who will present the Zeroplus project. And we're all members of the Zeroplus team. And I'll start with a brief introduction where we started from, and a good place to start is the decision that was made in 2010 by the European Parliament to introduce a directive on the energy performance of buildings. It's called the Hcpv, the Energy Performance of Buildings Directive, and it included many important decisions. One of them was that all new buildings would have to become nearly zero energy buildings. So they stipulated that from the end of 2018, all the new public buildings would be nearly zero energy. And then from the end of 2020, all new buildings would be nearly zero energy. And this is, of course, decision that will have a major impact on the construction industry. Let's start by defining what nearly zero energy buildings actually are. So those are buildings in which the regulated energy consumption, so the energy consumed for lighting and ventilation and heating and cooling, is more or less equal to the amount of energy that is generated from renewable sources, such as wind and solar energy. So as a result, the net energy consumption is close to zero. How close is a matter of some interpretation, but in the Zeroplus project, we defined this as a net energy consumption of less than 20 kilowatt hours per square meter built area per year. And it's important to point out that we refer here to the overall energy consumption over the entire year. So at any single moment in time, more energy might be consumed than is generated. At other moments, more energy will be generated than is consumed. So these buildings do have to be connected to the grid. They aren't autonomous in satisfying their energy requirements. Now, one problem with nearly zero energy buildings is that they are quite expensive to build. And this, of course, makes sense since they have to contain both systems to increase their energy efficiency, to reduce the energy consumption, as well as systems to generate that energy from renewable sources in order to gain that balance in overall energy consumption. And this might be a major problem. Many people find it hard to afford housing anyway. And if you make housing even more expensive to build, if you increase furthermore the initial cost, that will increase inequality, might increase energy poverty. So this was a major issue that we wanted to tackle in the Zeroplus project. And that's the major question that we wanted to answer. How can we reduce the cost of those nearly zero energy buildings? And what we came up with was a concept that expanded the principle of nearly zero energy performance from a single building to a settlement level. So our hypothesis was that if we do not require every single building in a settlement or a neighborhood to achieve nearly zero energy performance, but rather the entire settlement or neighborhood, we would be able to dramatically reduce the initial costs of constructing those buildings. And we thought we would be able to do so for a number of reasons. We thought there would be a number of benefits for expanding the scope of the concept of near zero energy performance to that of settlements. And the first one is the basic principle of economies of scale, which is well known in economics. If you buy a certain product at larger scale, if you buy a larger amount of a certain product, you'll usually be able to buy it at a lower price for a simple reason that the company producing and selling this product prefers to make a single transaction, single large transaction, rather than a large number of small transactions. So we thought we would be able to buy all those components and systems that are required for near zero energy buildings at a lower price if we do so at a settlement scale. Now, this is relevant not only for products, but also for services. And nearly zero energy buildings are quite complex, technologically complex. And you need specific experts to design and to build and operate them. And it's not always easy to gain access to those experts. So if you have a project that is at a larger scale, it would also be easier to have the access to those experts that you need to design and build those settlements. In addition, there are certain energy technologies which you simply cannot apply at a building scale. They're too large to fit into a single building, or they might not be relevant. For example, energy management technologies for the entire settlement. So we thought that we would be able to make use of those more efficient and cheaper technologies if we increase the scale. And for example, install such technologies in areas in between buildings and not just on top of the buildings. The areas in between buildings are also important when it comes to urban planning and improving the urban planning. For example, we thought we might be able to reduce the phenomena of heat islands, urban heat islands. It's well known that urban areas generally display a temperature that is higher than the open areas around them, increasing energy consumption to cool buildings. We thought we might be able to change the way the areas around the buildings are, for example, paved in order to reduce such an effect. And finally, when working at a settlement scale, it would be possible to use modular building technologies. So we would be able to prefabricate or preassemble certain modules containing different technologies. So that would then be much easier, much faster and cheaper to install them on the site, and thus reduce the overall cost of the settlement. We realized, of course, that there would also be challenges in realizing such a concept. First of all, as I said, there is a certain technological complexity which further increases when you use novel, large technologies. There are also a lot of stakeholders involved. We thought we would be able to create this energy community. That, of course, requires everybody to be able to get along. And this refers not only to the people who inhabit the settlement, but also to those who are involved in designing, constructing them, and in regulating them. The design process itself also becomes longer and more complex. It includes now not only the building design, but also the urban planning phase, which of course starts for a much longer time before the construction itself and might take much longer to approve. And finally, all those complex and long design and construction processes require certain novel tools and methods to be developed and applied. You'll be able to see some of those tools and methods that we developed in Zeroplus for this purpose in the next few presentations. So that's all from my side. I will, of course, stay on to answer any questions you may have at the end of this presentation. But now I'll pass the microphone on to Professor Marguerita Asimakopoulos from the University of Athens, who is also the coordinator of this project, and who will tell you a bit about what we actually did in it. So thank you.
Thank you, Shabtai. So I will be talking about, thank you, Shabtai. I will be talking about the Zeroplus approach and mainly what the benefits are, the concept of the Zeroplus approach, and what is it, what are the benefits, what can we achieve with it, and where it can be. So everything begins, as Shabtai already said, from the definition of the concept of the zero energy building. The zero energy building is actually defined in the EPBD as a building that has a very high energy performance. The nearly zero or very low amount of energy required should be covered to a very significant extent by energy from renewable sources, including energy from renewable sources produced on-site or nearby. However, what Zeroplus was aiming to do was to not focus on one building, but a whole settlement of buildings. So in order to move from the net zero buildings to a district level, the requirements are more demanding. NZE settlements, near zero energy settlement, should be places of advanced, we would say, social progress and environmental regeneration, as well as places of attraction. So there should be also engines of economic growth, which would be actually based on a holistic integrated approach in which all aspects of sustainability should be taken into account. Up until now, all efforts that have been put into quantifying and bridging eventually the energy, financial, and environmental gaps that still exist, between the cost-optimal combination of energy technology and the NZEBs were actually quite, we would say, not quite complete. Even though various innovative, passive and active, smart and even low-cost technologies are already available, the optimal integration is not yet completely, we would say, done. What is the Zeroplus approach, though? In order to understand what Zeroplus is about, we should see what it comprises of. So the Zeroplus approach, it actually consists of three phases: the design, the construction, and the occupancy. In each of them, we have a set of specific activities. In particular, the design phase comprises the planning and design of the buildings and settlement, with the emphasis given on planning for all design strategies and technologies that are supposed to be installed at the settlement level. This phase includes the building and settlement level simulation, which is done by using state-of-the-art simulation techniques, the initial integrated design, the design optimization, and the commissioning and monitoring and evaluation plans. During the construction phase and at every step of this phase, we made sure that collaborative and coordinated work between construction actors was ensured by following the detailed commissioning plan, which was prepared during the design phase. And of course, it's using the developed Zeroplus tools and guidelines. As the construction of the building progresses, as the construction of the building progresses, we are focusing on energy efficiency, renewable energy, and monitoring components, which are integrated into the building structure, of course, using the guidelines that were laid out in the commissioning plan. Once the installation of energy and environmental systems is completed, functional and pre-occupancy checks take place in order to ensure any deficiencies are handled and according to the commissioning plan. Finally, when we reach the occupancy phase, the activities related to this phase include the documentation, the collection and analysis of data collected from the buildings and the settlement level buildings, which is done using the WebGIS platform. And of course, this platform is accessible by all stakeholders involved in the ownership, operation, and maintenance of the building. This data, which is gathered in this phase, is adapted to the needs of each individual case. So we can use the post-occupancy evaluation protocol, which was developed during the Zeroplus project. The analysis of the data generated will eventually enable an optimal allocation of funds for the maintenance of the building and the settlement. What are the benefits of the Zeroplus approach? This is, I would say, a slide that contains a lot of information, but I will say a couple of words for each of these points mentioned out here. So the first point is that increased efficiency through the application of communal energy production and management technologies. What does that mean, however? It means that the systems upgrade will provide both economic and energy benefits. First of all, we achieve a reduction in the initial investment cost of the technologies, thanks to their sharing among the community. Moreover, the installation at a larger scale of more powerful system will be characterized by a higher energy efficiency, which is one of the main targets of this project. And at the end, the energy balance among the different users in the community grid will allow for loads and renewable energy use shift and cost savings. The second point is that we can achieve improved microclimate conditions through urban design solutions, leading to a reduction in energy demand and CO2 emissions. We've seen this point in every project that we know, so this is something that we can elaborate a bit. So these benefits have to do mainly with the mitigation of the outdoor microclimate, such as the overheating, as already mentioned by Shabtai, and other climate change related phenomena, and of course, reduction of building energy demand, and finally, associated with the CO2 emissions. All of these are achievable mainly thanks to the proper implementation of microclimate mitigation strategies. And the principal knowledge strategies are green and cool materials. So if you have some time and you can take a look in the Zeroplus project, you will see how all the mitigation techniques and all the new technologies were applied in the Zeroplus project. Were green and cool. Next point, optimal energy production through a proper technology design, integration at settlement level. Here it's actually exactly what is mentioned in this sentence, which means that the enlargement of the scale of analysis from the single building to the settlement level will allow for accounting for shared energy production and management systems. Economies of scale leading to opportunities for lower initial investment costs. We saw earlier in Shabtai's presentation, in the beginning of this one, that economies of scale is a main concept of Zeroplus, as the initial cost for producing nearly zero energy building is quite high. So in Zeroplus, we try to address this challenge by reducing the costs of nearly zero energy settlements by mainly reducing the balance of system costs of the technology through efficient production and installation processes. Customized and optimized solutions were developed for each of the case studies in this project. Automation is always implemented where possible, and all these are made to ensure efficiency and economies of scale, and thus reduced costs. Next point, enhanced building performance for the end users. We are discussing about the improvement in energy and environmental performance in terms of comfort, of course. These points are simulated for the proposed home energy management systems, for advanced lighting control systems, for different types of occupancy schedules and different modes of operation. And finally, advanced simulation techniques at high spatial and temporal resolution were used in order to create a range of profiles, of load profiles, one could say, in order to address different occupancy patterns. Finally, a life cycle cost analysis regarding the specific contribution of each of the selected innovative components was performed, and the optimum economic sizing was estimated. Given the estimation of the technical and economic optimum target for each innovative component and system, as well as optimization techniques, are used in order to select the final and optimized sizing of each technology and component. So if we could put everything together in a nutshell, we would say that without Zeroplus and ZEBs, that nearly zero energy buildings are expensive. They can be lost in a construction supply chain which is uncoordinated, and it is unsure how to achieve, people are unsure how to achieve net zero energy performance. While with the Zeroplus approach, we achieve optimization at settlement level, which reduces the costs. We ensure integrated planning and management of supply chain and construction processes. And finally, the methodology ensuring the methodology we're using will ensure optimal achievement of the near zero energy performance. So what Zeroplus can achieve? Application of the Zeroplus approach, as we already said, will ensure cost reduction, energy use, lower energy use, and increased renewable energy production targets. The achieved performance demonstrates the increased environmental and social value of the Zeroplus approach. So we can see now in this slide the targets set for the Zeroplus project. So net regulated energy of 20 kilowatt hours per square meter per year, renewable energy sources production of 50 kilowatt hours per square meter per year, and cost reduction of the building in 16%. In Zeroplus, the targets, as you can see below in the table below, the targets were achieved or were very close to achievement with the application of a number of innovative energy production, energy management, and energy conservation technologies, which were applied both at building and at settlement level. My colleague Kostas, who is following my presentation, will elaborate more on the specific technologies in his presentation about the monitoring platform. So where it is applicable? The Zeroplus approach has been developed initially for new settlements and neighborhoods, but it can also be applied and adjusted in different situation, in different retrofit, in different scenarios, mainly in retrofitting of existing settlement. And of course, it can be expanded into different uses of buildings. So Shabtai said a couple of things about the applicability, mainly on urban planning, building permits, utility companies, and service providers, which can, in which the Zeroplus approach can be applied. So as demonstrated by the Zeroplus project, this approach is also relevant for different building types, both public and private housing. It can also be used in single and multi-unit housing, and it is also applicable in a different range of climatic regions with different heating and cooling requirements. You can see below in this in the pictures shown below the different types of buildings where Zeroplus was applied. For example, in France, in a multi-story social housing apartment block, in Italy, in villas, in the UK, in detached and semi-detached dwellings, and in Cyprus, where it was applied on a prefabricated container system. So I would urge you to use the link which is provided in the end of this slide in order to get more information on Zeroplus and the way to design net zero energy settlements. Thank you for your attention, and I will give the floor now to my colleague Kostas Gombakis from the TUC.
Thank you, Margarita, for the presentation. Hello to all. Good afternoon. My name is Kostas Gombakis. I'm a member of the Technical University of Crete, and I was part of the team that designed the WebGIS platform and successfully implement the monitoring scheme for the Zeroplus project. As you know, in the Zeroplus project, we have 4 case studies across Europe, from the UK, across France, Italy, and finally in Cyprus. So in the UK, we have 3 houses. Each house is equipped with PV panel, Hive smart thermostat, and the Tesla battery with integrated inverter. In France, we have installed a solar panel called Dual Sun that has both production of thermal energy and electricity. Also, we have installed from one of our members, Energy MRE0C05. It's a PV panel. And we have a heat exchanger from the biomass from the urban heating network in the area. In the Italian case study, we have 2 villas. In the France case study, we have 3 apartments from the whole building. For the case study in Italy, we have 2 villas. In both of them, we have installed PV panels and another PV panel in the common area under the over the car parking, and both of them are connected using an inverter battery solution provided by our partner ABB called React Plus. And finally, in Cyprus, we have installed 3 systems from our partners. We have insulation for Fibran. We have a Hcpv concentrated photovoltaic system from Arca that produce both hot water and electricity, and one innovative HVAC system called Fresco that use the heated water provided by the Hcpv in order to provide cooling energy from the whole to the prefabricated demo box. So the basic principle around WebGIS platform was to support efficiency the monitoring of the case studies and collect all the data, both from energy perspective and environmental data, to have a quick and easy access to the data and the performance of each one of the system individually and as a whole. So for each one of the case studies and the majority of them, to implement an optimized maintenance methodology in order to reduce the downtime of its technology, thus minimizing the energy lost from the renewable energy sources, and to analyze the data. The core aspect of the WebGIS platform is that is built on open source technologies, and it's a cloud-based application. In the heart, it's a database that can communicate with the outside world, the 4 case studies to exchange data, so both get data and send data to the case studies. And then inside our cloud platform, we have developed some intelligent models for energy prediction, fault detection, for each one of the measurements that we get from each case study. And using those results, we run our methodology for predictive maintenance. The second option is to calculate the KPIs that we have set up for the whole project. And finally, we provide a GUI, a user interface for the users to interact with a platform that I will show to you later stages. Here you can see that we have quite a lot of different technologies that we had to implement in order to successfully get the data from the whole system. One of our key aspects, because we didn't have one partner that was the one that we will install the monitoring system in all case studies, we we choose, and was one of the cornerstones of our success, to implement and to require from each one of the case studies to use open standards and open protocols in order to implement their monitoring strategies. So in the beginning months of the project, we publish a white paper that we say, okay, in order to have a very good monitoring scheme, we want to measure these 5 or 10 points, and please, we want this kind of opportunity to get the data in order to have a uniform way in the final steps in order to receive the data from our platform. So we use open standards like KNX, REST API, web services in order for us to be successfully to getting the data. So you can see that we use from KNX IP routers to some proprietary platform from, let's say, ABB, Aura Vision, that collects the data from PV and energy production, to a backnet IP router, to various weather station providers, and all this achieved to have a very successfully final result. So in all our efforts, we finalize that we use 3 different topologies in order to get the data. The first 2 topologies are the most common one. The third one was let's say, a very specific one for our case, but during your work, you will have to deal with either topology 1 or topology 2. So the first topology, you have installed some monitoring equipment in your case study, and you can interact directly from the WebGIS platform or whatever platform you use to the device and get the data out or send the data. The second topology is the one that you have to speak indirectly with the device using the manufacturer platform. Nowadays, with the cloud, almost all smart devices have some kind of platform that the manufacturers have created in order to gather the data and present the data to the customer. So we use this kind of platform in order to receive the data from them. And here we have a very specific implementation for us, because we use some industrial controls for the Cyprus case study, and we implement the backnet TCP protocol in order to get the data. I have to stress that in all our implementation, we always use encrypted channels to transfer the data from in any transfer that had to deal with internet. So if we hadn't this kind of flexibility to have encrypted channel, we didn't allow this communication. In the process of Modbus TCP, it doesn't have any encryption or protection. So that's why we needed to implement a virtual private network between our WebGIS platform and our Modbus TCP controller, that we would get the data from it in order to have an encrypted and secure way to get the data. Here you can, here you can see, let's say, an overview on how you can, different technologies can get the data. So here we have a KNX IP router that it connects to the heat meter that is installed in one apartment. It reads the data and communicates back to the WebGIS platform by REST API or web services. Next, we have the inverter that gets the DC voltage and current from the PV panels of the from the source and gets and reduce it to the grid, and we get the data through the third-party manufacturer platform. So with the use of open source and open standards, we can implement and receive data from quite a lot of different sources. And here is what the WebJS platform, the front end, the user can see. So we have a page that you have to log in. For us, the first and most important issue and care was the privacy of the personal data and the data of our case study. So we take a very big care of the data and data protection in order to see. Here you can see the 4 case studies. We can, let's say, click on one of them in order to get into the next level. Here you can see what is the look like. Here we can see the case study buildings, and we have this kind of information window with the overview, some general information. We have some detailed information about energy production, energy consumption, indoor environmental quality for the settlement level and the building level. We have the historical data for all the buildings on the settlement or the building level. And if we click on a building, we get a level down to get a more detailed information about the building. So we can see how here the past 24 hours, the energy production and energy consumption, the overall energy production, some basic information about the building. And here we can see more details about each one of the different devices types that we monitor in order to get the consumption of them. And you can see for every hour for the past 24 hours what was the consumption per different type. Here you can see the production. And finally, for every month, for every one of the case studies, we implement this kind of monthly report that we use to summarize the indoor environmental quality indices, so the temperature, humidity, CO2, maximum, minimum, average, the energy consumption, energy production, and here we have the KPIs. So we use the calibrated simulation model for each one of the buildings in order to see from the simulation for that particular month what was the production consumption for that building, and to see if our simulations model are in line with the actual consumption. If we had a very big difference, we go back to the simulations to see if we had run some wrong on the simulation, or we go back, we'll go to the case studies to see what is happening. Thank you for your attention. I give the floor to Professor Anna Laura from the UniPG to discuss a little bit more about the Italian case study.
Good afternoon, everybody. So thank you again for following this workshop. I'm Anna Laura Pisello from University of Perugia, Italy, and I specifically deal with the energy communities. So those, let's say, people who basically aim at occupying our Zeroplus net zero energy settlements. So I will go through some premises in order to be focused immediately after on European and national legislation, with a further focus on the Italian condition and all the rapid, let's say, evolution we have been facing during the course of last 1 or 2 years, in order to finally highlight what's still needed. So about the energy communities, most of the regulations and scientific papers and shared documents deal with energy communities as community of buildings, energy systems, but also and mostly people, with the several shared objectives of being, let's say, green, efficient, decentralized, and democratic energy systems integrated within a global framework, also including sustainable economy and toward climate neutrality. The big change that involves the concept of energy communities is also related to building occupants that act as consumers, as typically happens in all the buildings, but also who act as prosumers, so capable of producing and potentially selling the energy to their neighborhoods, with some final purpose to produce environmental benefits, economic profitability, even if the economic profit has not to be the very first objective, so it has not to be like a kind of economic framework around this as only scope, and mostly social benefits for the community in order to start sharing facilities as part of the social, let's say, the social transition that energy communities want to implement. So what's going on about, let's say, for facilitating this kind of implementation? The first directives and European scale standards were the Clean Energy for All Europeans package, Renewable Energy Directive of 2018, number 2001, and the Electricity Market Directive, the following year, number 944. The very first reference, so Clean Energy for All Europeans package, includes 5 dimensions that has to be touched with the incorporation, let's say, within the incorporation of energy communities, but not only related to this. So innovative approach, interconnected approach, of course, mostly, let's say, suitable for energy communities, inclusive, again, super suitable in terms of energy community, but also to be safer and therefore, let's say, more resilience with respect to a variety of forcing, investment friendly, mostly digital, as my colleague previously showed up, and socially fair. This is another key component specifically, let's say, involving the energy communities concept. This framework has to be, let's say, implemented from the energy union governance and therefore at a later stage on national and even local basis in order to pursue energy efficiency, renewables, new markets and new design potential for these, let's say, mostly electrification trend, and also for better managing energy prices and, let's say, business models. Again, the same standard made a key difference in between self-consumption and energy communities. Self-consumption is currently already implemented in most of the European countries, in particular in the form of individual self-consumption. That, of course, consists of the fact that renewables are implemented in specific buildings who consume part of this energy which is produced. But what is going on is to try to push collective self-consumption in order to push energy sharing concept, also for optimizing its environmental sustainability and increase shared environmental interest and benefits. Pushing even further, the concept of energy communities expands this only energy sharing system, because it is a legal entity realistically created by citizens, but potentially also by small, medium enterprises, local, public, and private authorities, and any other user with the potential possibility to sell, integrate, and even buy energy from their neighborhoods. Then it's controlled by its members. It's not primarily focused, as I was mentioning before, on only financial profits. And it has to provide social, environmental, and economic benefits at the level of its members, but also on the related stakeholders. The purpose is, in fact, to kind of, let's say, prepare the proper field for all the commercial and non-commercial actors, citizens first. The following directive is the Electricity Market Directive, also because, as you can guess, most of the, let's say, innovation has to include an important market deep change to be realistically made operative. So the consumer is an active consumer that is able to consume, but also to store energy in the form mostly of electricity within their premises, but also considering the specific boundaries of the community, so sprawling a bit the boundary of the single building scale, as we could see with all the presentations of my colleagues. And of course, they can be able to sell self-generated electricity. While the citizen energy community concept within the same directive basically deal with, let's say, a kind of corporate in the form of energy community, specifically, let's say, made and populated by citizens and also other stakeholders within the same framework of the previous European standard of clean energy for all Europeans, as I mentioned. The following directive, Renewable Energy Directive, basically dealt with self-consumers and their definition as a group of at least 2 jointly active renewable self-consumers. They have to be in the same buildings, they have to generate or to be capable of generation of renewable electricity, and they may store and sell self-generated renewable. If this is true, then they are entitled to build up a renewable energy community. So we can differentiate this citizen energy community, so with the boundaries specifically designed by even 1 or more consumers, with respect to the renewable energy community that has been populated by at least, let's say, 2 or more users, producers, and let's say users that can also store energy. So the concept is in between citizen energy community and renewable energy community, with the big difference that is located in terms of participation, as I mentioned, but also on a spatial, let's say, dimension. In particular, renewable energy communities have to be in close proximity. In the Italian regulation, this is basically translated into the fact that they have to be provided by the same, let's say, electricity final line of the national grid in order to be considered as in proximity. But in all the European countries, of course, in the national implementation standards, there are specific regulations stating what does it mean proximity. Both of them have the purpose to create field communities with some specific difference in between the energy community of citizens that may be even just citizens without any kind of legal links, while renewable energy communities are relatively more oriented to multifunctional users. Let's say to the combination within the same community, also for optimization purpose, of different users, let's say residential with commercial, with institutional and other uses, in order to be able to produce energy and not to use the same produced energy for all the users at the same time. That's the reason why renewable energy communities have somehow the indication to be framed according to these differences. As a startup of this concept in Italy, under the framework of Zeroplus, we have been cooperating in order to finalize the design and the construction of a very small neighborhood that basically consists of 2 single-family buildings located in a construction larger area. And theoretically, these 2 buildings had nothing specifically in common in between one to each other. This implied that since we started Zeroplus before the energy community implementation in Italy, we had no chance of doing anything in terms of energy connection in between the 2 houses without the Zeroplus project. So while, of course, all the national regulation have been changing during the last, let's say, a few months, and that's the big progress that our country and other countries are facing. These 2 houses present several strategies and technologies in terms of energy efficiency, like the Hcpv, and other active systems like the air-water heat pump, the integrated photovoltaics panels, and so on, which were specifically provided thanks to the, let's say, design framework of the Zeroplus settlement. And on top of that, we also cooperated for selecting mitigation strategies, let's say, against overheating in both the indoors and outdoors, always according to the net zero energy, let's say, platform design proposed and implemented by Zeroplus. So basically, as I mentioned, we face in Italy specific policy barriers. So the impossibility, simple impossibility to implement any kind of community contract. Second barrier, the user acceptance. Of course, at least here in Italy, but in most of the country, when you want to live in a detached single-family house, typically you are not that willing to implement shared facilities and contracts and so on. That's the reason why these specific social barriers have to be faced and crossed with dedicated intervention and, let's say, further benefits. Technical barriers, permissions, again, related to contracts, related to standards, and again, privacy and intrusion. So these basically two big categories of barriers: standard, that implies permissions and so on, and users and social, that implies privacy and intrusion. Some very few information about the regulatory framework you can find in these slides. We started with Mille Proroghe decree, so last year, but then we started really implementing energy communities at the beginning of this year. And of course, this was a bit slowed down by this crisis currently going on, but I have to say that 3 days ago, the final executive decrees enforced. So theoretically, today, we could design energy communities. Here, there are some contents about the energy communities decrees, and basically it is the linear and direct implementation of the European directive I showed, with some extra limitation in terms of overall power that has to be 200 kilowatts installed maximum in each community. And of course, they have to establish their legal independent status. So again, all the standards, let's say, brought as a consequence the implementation of the incentives and calculation models national standard that established 3 days ago, as I mentioned, the tariff of 100 euros and 110 euros on respectively collective self-consumption and energy communities. And this should be valid for 20 years. Of course, how's the market changing? The market is deeply changing, hopefully, let's say, thanks to the very recent national implementation, where there is a key information already, let's say, inputted into the standard, the national standard. The pushing to be made by much granular local authorities to establish at municipality level those kind of round tables and information desks in order to facilitate the mobilization of private capital in order to increase the flexibility and to start dealing with the collective self-consumption and energy community of prosumers. Thank you very much. And I give the floor to my colleague, Professor Salvatore Carlucci from the Cyprus Institute.
Good afternoon, everybody. Thank you very much, Anna Laura. It's a pleasure for me being here with you and try to summarize what we have done in Cyprus at the Cyprus Institute with our pilot case. I'm a professor at the Cyprus Institute in Sustainable Built Environment, and I've been working on this project together with great consortium. So the start that we have is what's the future for the building sector, in particular for the building here. And as we know, it's quite challenging since basically we are looking towards a complete change of conditions with an increase and exacerbation of local climate change. We are seeing in any case an increase in energy and resource consumption. The building stock is quite old and made mostly with a low quality. We are experiencing urban heat island that in summer-dominated climates is challenging. Then the urban vulnerability is really big issues for our communities, and also energy poverty. We have to keep in mind that not everybody can easily try to deal with the cost of energy. So how can we react to these? Several receipts or instruction or suggestions have been provided, for example, by European Union with their calls, with their evolution of a research framework, and also with standardization, of course, and national legislation. What we have been speaking here is the nearly zero energy target that has been a very inspirational principle some years ago that is fully in force now. There is the issue of sustainability that is a leading concept that is trying to give a guidance to our research, and then other kind of aspects like energy flexibility, and of course we have to keep in mind also economic balance of our projects and maintenance and besides this. But most of all, we have to keep in mind that we design and build buildings for people, and so they must be healthy and comfortable. What we are doing at the Cyprus Institute is basically try to work on different aspects. We have been working here with the Zeroplus project, that is this European Union funded project, plus we have another project that is Smart Gems, and just recently we have been awarded another project that is MESH, is a project that is funded at national level, where we are trying to diversify different approaches to respond to the grand challenges that we have been introducing right now. Within Zeroplus, we have created this is our settlement here at the Institute, where we have brought some technologies. We have developed together with the technology providers these technologies, and we have deployed them, monitored, and used in order to see how would they performed. And all of these has helped to increase the technology readiness level of these devices that we have installed. We have two basic elements. One is called the Frisco, and the other one is called Hcpv. The Frisco is an innovative desiccant and evaporative cooling technology developed by Solar Invent. It is basically an heating, ventilation, and air conditioning system that provides different services to a building. Air change, so ventilation, controlled mechanical ventilation, dehumidification, space cooling, space heating, and heat recovery in a very efficient manner with a typical energy efficiency ratio that is higher than 10 compared with conventional system that range between 2.5 and 5, offers different energy savings and CO2 emissions, possibly offer the possibility for free cooling, provides high indoor air quality. And what is extremely interesting is that it does not use any dangerous substance in each thermodynamic cycles. It's also pre-assembled and ready for installation. This was the first the device of the Frisco, the first version of Frisco, developed 6 years ago. Along the time it has been optimized, and basically to overcome some drawbacks. For example, the limited capacity in terms of refrigeration in production, the high in weight, and the let's say the not easy capacity to be positioned on solutions that were not a roof, for example. So this brought to an evolution of the system. That was this one that is much easier to be integrated, and this is a view from the inside, but still is quite interesting component that needs quite a lot of preparation to be integrated. So the system was basically along the European project Zeroplus has been developed from these to this other version with the re-engineering of the system, optimizing the layout, the integration, and now has been in this way installed in our prefabricate unit. It is an air quality observatory, and basically now also another element is that the solar collector field has been decoupled by the system, so now it's has much more flexible installation potential. Furthermore, the system can be equipped with a double flow air change unit that will make this system very capable of respond to the needs of small houses, small offices, and residential units. Very effective, and actually also in the context of COVID-19, the solution is very effective since it does not provide any kind of mix between the indoor air extracted from the inside and outdoor air taken from the ambient outside. The second system is the Hcpv, that stands for High Concentration Photovoltaic and Thermal System. It's quite interesting solution that basically conveys solar rays into secondary optic, and the secondary optic align the solar rays towards a multi-joint solar cell that is characterized by a quite high conversion factor. So we have some mirrors, a fustum, and then the solar cells. These are the three elements of the system. This system has been designed in order to be very effective. It has a concentration factor up to 2000 sun. That is a quite outstanding result. What is the cell? The cell is 1 by 1 centimeter multi-joint cell that basically is capable, at least in nominal condition, to have a conversion factor from solar to electricity of up to 46%. Overall, the system has some losses, so in general, the electricity efficiency is in the order of 30%, plus there is the generation of hot water, wastewater that is used for other applications. In this scheme, you can see on the bottom the cell, then you have the cooling system, and then the water that cools down the back of the cell to a temperature of about 100 degrees in order to keep it in the range of operation of the cell. This is the computational fluid dynamics study of the cooling systems that has been designed specifically for this application, and this is it, where you can see the fustum, so the secondary optic here, and then the cooling system with the water coming here, cooling down the cells, and then the water is then put into a tank. This is the modules are mounted on a double axis tracer that is able to adapt with respect to the different azimuth of the sun and different height, solar height. Generally speaking, the system is characterized by peak power generation of about 1 kilowatt and thermal peak power generation of about 2 kilowatt. It also delivers hot water at a temperature that might be up to 70 degrees, and the combined heat and power efficiency is between 72 and 85%. This is a picture of the system that you can see with the 20 mirrors. And the system, since it generates electricity, is combined with an inverter and a battery arrays that provides us capacity to shift the power generated for other applications into the building. What we have tried to do is to combine the two systems. So we have here this scheme where we have the Hcpv that generated electricity, then hot water that goes into a tank, and this tank is connected towards a solar collector, and there are some logics that have been designed, and according to the source that can generate the proper with the level of hot water, then water is sent to the fresco in order to cool down the beds. And then there is also the treatment of air, where we have ambient air that is pre-cooled and then cool down to set point temperature and then sent into the building. We are very happy since both these two technologies were included into the collection of the energy efficiency in buildings, PPP, promising technologies in 2018. And yes, it has been a very nice experience to work together with technology providers in order to construct this case study, monitor it, and provide new options for designing the settlements of the future. With this, I would like to thank you all, and thank you, Dr. Montagnino and Dr. Finocchiaro, that helped in preparing this presentation. And with this, I would like to give the floor now to Dr. Sven Köhler of Energy. Thank you very much.
Yeah, and thank you so much for the presentation. My name is Sven Köhler from the company Energy from Switzerland, and we were a part of this project as technology providers. And I would like to talk a little bit about the benefits and worries for technology providers on such projects. We speak a bit about the technology readiness level and how we went further with this, the EU project's effects to us as a whole company, give a little outlook and a summary. So TRLR advancement, well, you have to understand, first of all, how such a project really works, right? So we got invited in 2015 with an initial sketch of the project, and we had 4 different sites to look at with 4 different types of buildings, and all looked pretty well for us, and we happily applied, right? And everything was nice. And then the next step is iterations, right? We really worked together as a team. We formed the Zeroplus team out of many different companies and universities, partners, and the level of iteration and setting up this teamwork is really quite a high amount, and basically we're not so much used to it as a small company. You know, normally our projects, customers, they ask for feedback until end of the week, right? And here it was more like a 1-year iteration approach. So we changed buildings, we changed view on buildings, we changed quite a lot. And for us, this means quite a uncertainty of what should we target, where should we go to, and we were just not used to it, to let's say also the deepness of the analysis of the iterations, and it was a good learning process for us. But as you will see in a second, also difficulty for our technology and how we go forward with it. So when you look at the realization, right? Initially, we have been part of 4 projects out of 4. And finally, during this iteration process, we have seen that that becomes more and more difficult for some of the projects to participate with what we can offer, always with the target of a near zero energy settlement, right? And so finally, we are happy to participate on one of the buildings with our technology. So it's not a straightforward way, and the same then happens to actually the technology development. If you look at what we have been invited for this project is actually this technology, which we called Windwell. It's a combination of wind usage on the roof edge and solar, right, to provide renewable energy out of wind and solar in the same area. And basically, during this iteration process, we have pretty soon seen that this product is not so much the right product to at least 3 out of the 4 sites. And so we decided to develop it further. In one way, the wind rail has become an MRE hybrid. The MRE stands for multifunctional roof edge. So it emphasizes more and more this multifunctionality here, beside using wind and sun to put out electricity. And on the other side, for pitched roofs, we decided to make a derivative out of our knowledge from wind usage for actually pitched roofs, which we call a B60, which stays there for 6 square meters of wind area, which is swapped. Yeah, but during these iterations, we have seen that even with these 2 products, it's actually not going to work. First of all, for flat roof buildings, the one in the project suddenly get another building in front of this flat roof building. So basically it killed the wind usage because there was not enough wind anymore to this building. So we said, well, okay, that is not, let's say, economic feasible anymore. And we developed this further from an MRE hybrid to an MRE light, which finally has been developed and realized. On the B60 side, it was more from a building permission perspective that there were some potential issues, and so the site owners have decided to stay away from it for now. But internally, we developed it further, and it's basically, meanwhile, a new product also in our portfolio. So looking at the TLR advancement, right, it is not really a straightforward thing as you normally would see it. And I don't know how often this happens to SMEs in such projects, but at least for us, it came out that we have to develop new products within this Zeroplus project to fit to the targets, right? And so the learning we really have is that this TLR methodology does not so much reflect which we call the market feedback, because it was also kind of a market feedback, the use cases. And we often went back to develop new things, which in the end of the day was pretty beneficial for us and for the project. So looking at the Zeroplus project effects to us, well, there is first of all an effect during this project, and then there is an effect afterwards, right? During the project, as already mentioned, this product development is really the most beneficial effect we had out of this, together with the project realization, which is, at least in the housing industry, real estate industry, a super important element to show, look, it's there, it's real, go and visit it. Otherwise, people don't believe you, don't trust you. Well, the only, I don't want to call it the negative aspect, but the ambivalent aspect is the financing, because obviously we or any other partner has planned that we put so much effort into these iterations and development of new products for the Zeroplus. So for sure we spend more as we were planning to, but nevertheless, this is not in a negative way for us, as we get a good benefit out of this for the product development, which we would have to be done anyway in one or another way. On the medium-term effect, actually, there is not the huge effect we really expect out of this project. I mean, for sure, there will be kind of new markets for this, but this is not just because of the Zeroplus. It's also that the whole regulation and actually market goes into it. For us, this means basically we can easily participate and benefit from it, and also do the communication with the Zeroplus in some cases. Many of our customers, so building owners and architects, are not particularly interested into Zeroplus, I have to say. So, but what we always try is to make them aware that it exists, and in some cases really trying to motivate them to go in this direction. Yeah, so on the outlook side, basically we have seen that this new product, the MRE, is now part of our portfolio. It's really a nice product which helps a lot of buildings to become better in terms of sustainability and renewable energy generation. If you want to see more about it, I click here on this link. You will see a little product catalog. As we are far in time, just to summarize, so basically the Zeroplus project participation for us was really good for them to shape this market offering. The realization of the pilot project was the main thing for us, financial wise, well, and the project participation as such has really helped us to bring our innovations more towards the market, and from that perspective actually was quite beneficial. So thank you very much for your attention. Now it's time for questions to all of us. If I understood this correctly, I give back to my colleagues. Thanks again.
Thank you, Sven. Thank you all the panelists for these very interesting presentations. Many things to discuss, many matter to cover. We are indeed a bit late in time. I hope we will be able to go through 3 rounds of questions, and we can already set 5 extra minutes after the program time, so we will be ending at 4:35. I will start with 2 general questions addressed to Dr. Shapti. One is about the energy performance of the case studies, the pilot projects, and how was considered the passive and envelope orientation performance of these projects before the production of energy, if the buildings are to a passive house performance level. And also a question from Gretel Shulamith asking about the steps. If I want to apply the Zeroplus approach to a new settlement, what are the exact steps I must take for the implementation? So if you may address these 2 questions for the moment, Dr. Shaptai.
Yes, thank you. I can start. Of course, my colleagues can help me. As for the passive house standard, no, it was not globally applied in all the case studies. It might actually not be relevant in all of them, since we had 4 different case studies in 4 very different types of climate. It wouldn't really be relevant, I think, to apply the passive house standard in Cyprus, for example. What we did do, however, is address of course, the energy performance of the buildings, regardless of the generation of energy from renewable sources. So we did want to improve and optimize the energy efficiency of the buildings themselves, also through passive elements, in particular the level of insulation, which we addressed. One of the partners in this project was Fibran, and we used some of their products in order to improve the level of insulation of the building fabric and thus reduce energy consumption. Of course, we analyzed this using energy simulations in advance. And as Kostas described, we're now also tracking the actual performance of the buildings after they have been constructed and occupied. And they do perform according to the expectations. So as for the second question, regarding the steps that you have to follow in order to implement such a settlement. Well, that requires quite a long answer. There are many steps. And we really, in this project, one of the main things that we did was to develop this process, to define this process and all the steps that it includes in the different phases of design. As I said, you need to design the building also in order to improve its performance, but also in order to make sure that you can integrate those technologies that are required, both for generating and for managing the energy. Then you have to also plan very carefully the actual construction process. Many of those extra costs that you incur happen during the construction process because of all kinds of unexpected problems that emerge. And then there are several steps that you have to follow during handover, for example, commissioning of the different technologies and of the entire settlement. And then, of course, the actual operation, the maintenance. So I think it's difficult to answer this in just a minute, but I would encourage you to follow those links that are included in the presentation. And there we have quite a detailed descriptions of the entire process and the different steps that you have to follow and the different tools that you can use in order to support those steps. And if you have any additional questions, I would really be happy to answer them through an email. And of course, so would my colleagues, I expect. So I hope I was able to answer those questions in a short time.
Yes, I think so. Very good elements. I will address a couple of questions, maybe to Marguerita. One is if you may clarify what is the baseline for the cost reduction calculation, and also if you can mention what is the most innovative aspect of the Zeroplus project approach.
Yes, thank you, Camilo. I will start from the last question, which eventually will bring me to the first. So the most innovative aspect of this project was that we moved from the building level, which was what was the focus for most projects, European projects at the time. So we moved from the building level to the settlement level, and we addressed the issue of cost. It is always a big problem when you want to apply what you know about near zero energy buildings, and you realize that this is a very expensive procedure. So you end up trying to calculate how many years it will take for this investment to eventually show its benefits on what we would say a financial aspect. So Zeroplus was actually had a very big ambition, I would say, an ambition which said that I know I can have a near zero energy building, but how about having a zero energy settlement, nearly zero energy settlement, while I will be using this economies of scale in order to reduce the initial investment cost. So we can understand that one of the most important KPIs of Zeroplus was to reduce the initial cost of actually building a nearly zero energy building. So you can understand that this question, the last question that you asked, its answer, it drives you directly back to the one that was posed in the beginning. So what we are trying to do via Zeroplus and this concept of Zeroplus and this ambition of Zeroplus is try to reduce the initial investment cost by 16%. So we would actually say that, and one can, as Shabtai already said, one can refer to our online documents and material in order to get more answers on how this cost can be reduced. So if we can say a couple of words on how this cost will be reduced, I think that we can definitely mention the way that nearly zero energy building is initially the cost for nearly zero energy building is initially calculated. So you can refer to our online guides and you can see the way that we have tried to calculate the sorry about that, the way to calculate the cost reduction for the energy, the nearly zero energy settlement. I don't know if we have time for me to explain more.
Yes, I can.
Okay. So
we continue, and maybe I would just address a question addressed by David Pilzer that I think is relevant, and if you may also explain. But because he says, I was disappointed with the size of the projects. They are all quite small and do not reflect my thinking of settlements. And you did highlight the relevance of the district and neighborhood scale, and the projects that I believe are very fastly developing the time lapse of the project, but it remain of a rather short scale. Small scale. So if you may also give a word of explanation on this scale of the project.
Would it be possible to repeat the question, because I think I lost some parts of this. Is it possible to repeat it, please?
Yes, I will repeat. I let you finish with the explanation of the calculation of the cost, and if you also may add to this question that Mr. Pilzer asked, because he says, I was disappointed with the size of the projects. They are quite small and do not reflect to my thinking settlements. And indeed, you highlight the importance of the neighborhood or district scale, and the projects are of small size.
Okay, so I understand about this disappointment. As you can probably imagine, this was a project that started in 2015. So you can understand that this was a very pioneering project at the time. We actually wanted to create buildings from the beginning in order to make up a settlement. So the idea of settlement, and of course, Shabtai can jump in at any time, the idea of a settlement at the time and for the amount of the budget that we had was quite, I would say, limited. So we can tell that from the French case study, where we have the social housing application, we had a bigger number of apartments that were part of this settlement. On the other hand, in Italy, we had 2 villas that were built from scratch, and they were trying to implement this idea of settlement. And one of the main ideas of the settlement was the idea of storage, of trying to store energy in order to use it on a later stage. But this was not quite quite successful at the time, since we had a lot of legislative and other barriers that went our way. So initially, the project with this very limited budget could not extend to more than the original, I would say, value or cost or budget for a nearly zero energy building. The way the cost was calculated, and of course, you can see it in our documentation as well, is that we calculated an initial investment cost for a typical near zero energy building in every country that had a case study, and we reduced that cost by approximately 16%. So the ambition, as mentioned, of Zeroplus was the one that it was described in my presentation in the beginning, showing a graph that was depicting the cost of a nearly zero energy, an NZEB. It's easier for me. So for an NZEB, and Zeroplus had the ambition of reducing the cost that we know it's necessary for an NZEB. Such a cost was calculated to be approximately 300 to 350,000 euros. And of course, this project would only finance this investment and not the whole building construction. So Zeroplus is referring to buildings that were actually had their own funding, and Europe would only finance the part of the NZE settlement. So there are two reasons why this project could not be bigger. One is that it was a very novel idea at the time, so the idea of settlement was not quite as it is now. We're discussing now for about communities and not settlements anymore. We're discussing about communities and districts. So at the time, Zeroplus was very innovative, since and no one had suggested anything about settlements at the time. And of course, there was a specific budget, limited budget, we would say, in order to see if this approach could work. I hope I'm answering the question. Shaptai can help me out here if he feels that he can add something to the discussion.
Or maybe a word of conclusion from your side.
Okay, so yes, Zeroplus is what I've been calling the work of a lifetime. It's a project that's been going on for 5 years. It is quite a dream that was realized, and now we are trying to take it a bit further. We have managed a lot of things during this project. Mainly, it was one of the few projects that managed to complete all case studies, which were, I have to say, new developments. So this was quite hard at the time, especially if someone can consider, if one can consider the trouble one gets in with permits, with legislation, with construction in general. So this was a project that was quite was successful, even though very ambitious. And we are really happy to have gained a lot of knowledge from this. And of course, this knowledge was not only positive lessons, but also some of the negative, in quotations, results that we got during this project. But this has made us better, has given us more ideas. We feel proud about this project, even though now it would be considered to be a small-scale project, but this has opened the way and is leading the way towards bigger developments in a more, we would say, community level, rather than a settlement of 2 houses or even 10 or 15 or 20 apartments. I think that Zeroplus was really successful, and it managed to fulfill all the KPIs that were set in the beginning, which is usually something quite hard, especially when the KPIs are set so high.
Okay, thank you very much to all the panelists. Thank you all for the audience staying until the end. And I'm truly certain that this is leading a very interesting way, and of the relevance of the neighborhood and district scale for addressing energy efficiency and better construction and building practices. So thank you all again, and see you in a new webinar in a coming time. Thank you. We're closing here. Bye.